Hello, welcome to APES Chapter 21 Lecture Video Part 5. This is the end of our chapter. The very last energy source we're going to talk about is hydrogen and hydrogen fuel cells. Why are we talking about them at the end? Well, it'll make more sense in a second. Most of the other types of alternative forms of energy and the renewable forms of energy we've just been talking about lately, they are intermittent. They're intermittent renewable sources, which means they're not available all the time. And when they are available, we make electricity at that point. So when the sun is shining, we make electricity with photovoltaic panels. When the turbines inside of a dam are spinning due to water rushing through, we're producing electricity at that moment. The only way to store that energy would be to not have water running through, but then that might dry up things downstream. So you got to be careful. So what happens with a lot of these renewable energy sources is they create electricity right away. So it's difficult storing large quantities for uses when you need them. So we got to make batteries. The big thing now is all this technology we're developing better batteries. That's where a lot of it is going. And the battery technology limits a lot of our capabilities. Like if you have an electric car, you go on a long road trip, you got to stop and charge it for a half hour to an hour to 45 minutes, depending on what kind of car it is and where you're trying to get to. So the big issue with a lot of these renewable types of energy is storing them and using them later. Well, hydrogen could be an element or a chemical in this case, or a molecule that we store that energy in, and then we use it when we need it to create electricity in this thing called a fuel cell. So fuel cells can produce the electricity when we need them by releasing hydrogen. All right, so what happens? What happens in a fuel cell? Well, fuel cells, you have hydrogen, that's the fuel. And what are they all designed? Well, fuel cells are designed on these reactions called oxidation reduction, or oxidizing and reducing. When you're doing an oxidation and reduction reaction, an element will get oxidized and lose electrons. When it loses an electron, remember the flow of electrons can lead to an electrical current. Something else, oxidation always happens with reduction. So if something's oxidized, something will be reduced. Well, you need something to get reduced in the process. So in a hydrogen fuel cell, the hydrogen, H2, gets oxidized. It gets oxidized very easily. And it gets oxidized very quickly. It loses electrons. All right? That goes through what's called the negative cathode, called the anode, and it moves towards a positive side. So the electrons move, and that's a current that is generated. So that creates electricity. The movement of those electrons creates the electric current. Well, oxygen is also needed in a fuel cell because hydrogen gets oxidized. Something needs to get reduced. Oxygen will get reduced, or reduction will take place. So the oxygen will pick up the electrons that made their way to the positive cathode, the positive electrode called the cathode. So the electrons went from an anode to the cathode. Over here you have the oxygen. The oxygen reacts and picks up the electrons and picks up these hydrogens, forming water. So water is the waste product of a hydrogen fuel cell. You could have different fuel sources. It just requires oxidation and a reduction. But the reason hydrogen fuel cells work nicely is the waste product is beautiful. It's water. And we don't really even think of water as a waste product because it really isn't. So the whole idea behind this mechanism is to have hydrogen store the energy. The thing about it is, to make hydrogen, you need electricity. So you produce this electricity using renewable energies, and that renewable energy then can go into making hydrogen so that you can use it as a fuel later when you need it. And I already mentioned a lot of this. The energy is released during the oxidation reduction reaction. Hydrogen is oxidized, or oxidation takes place. Oxygen reduced, or its reduction takes place. Water is the result. And here's the basic chemical reaction that takes place. Hydrogen gas, two of them, plus one oxygen molecule, makes water. No pollution is produced. Water is not a pollutant. This whole idea, this whole concept it's dependent on renewable energy, because renewable energy, we're going to talk about in a second, is needed to produce the hydrogen fuel. Hydrogen it's a very abundant element on our planet. It's the most abundant element, I believe, in the universe, because the sun is a giant ball of hydrogen for the most part, getting converted into helium. So hydrogen, we have a lot of it available. The whole idea is using it as a fuel we can transport and utilize it when we need it. A lot of, you may notice every now and then, you may notice buses, and they'll say they run on hydrogen fuel. That concept is being used in certain buses in some places. All right. So in order to have a hydrogen energy economy, so hydrogen as our fuel source, we need to make hydrogen. And the process of making hydrogen requires an input of energy. Because what you got to do is you got to rip hydrogens away from something else. So that requires energy to remove them. So we call the process of producing these hydrogens, this process is called electrolysis. Electrolysis is when you input electricity and you take an otherwise non-spontaneous, a reaction that did not want to happen, and you make it happen. So in this case, water does not want to split apart. Hydrogens and oxygens, H2, they want to stay together. But so in order to rip them apart from each other, we need a non-spontaneous reaction. Had a reaction that doesn't want to happen. To make a reaction happen that doesn't want to happen, it requires energy. We zap water with electricity, and if we zap it with enough energy, it will get converted into hydrogen gas and oxygen gas. Okay, that's how we can make hydrogen. This is the best way to make it if you're trying to do things renewably, because look, your waste product is oxygen. Your whole goal is to utilize your hydrogen in the fuel, which will eventually be turned back into water, and then there's the oxygen that we can breathe. Now, the issue with electrolysis is that most of the hydrogen on our planet isn't made using electrolysis of water. I believe 90+% of it is done with the electrolysis of a natural gas like methane. So methane, the reaction here is methane and water. You zap them with electricity, and you create hydrogen and CO2. So this is the way, hydrolysis of methane is the most common way they're currently producing hydrogen gas. This is not good, because look what's being released. Greenhouse gas, carbon dioxide in this process. So if we're going to shift towards a hydrogen economy, hydrogen needs to be, ideally, to do things renewable and clean for the environment, it needs to be done using the hydrolysis of water, not the hydrolysis of methane. So currently, hydrolysis of methane is what they're using. Why do they do hydrolysis of methane? Because it's cheaper. It takes less energy to do electrolysis. To do electrolysis on methane. It's much cheaper to do electrolysis on methane than it is on water. It requires more energy to do it to water. So it's cost effective to do methane, but you're now producing greenhouse gases as an emission. And I mentioned a lot of this material here, the cleanliness of hydrogen. It also depends on what fuel are you using to supply the electricity to do electrolysis. Did you use a fossil fuel to make that electricity? Then this whole process becomes very dirty or not clean, you could say, and it becomes not renewable. So ideally, you got to use a renewable energy source to generate electricity, and then that electricity then can go into producing hydrogen gas, but ideally electrolysis of water needs to be the method that they're using in order to make this clean and renewable. Fuel cells produce electricity. How do they do it? I've already mentioned this to you. Hydrogen ions pass across through an anode, through a membrane. As this happens, they get oxidized and lose their electrons. That creates a current that's picked up on the other side at the cathode, and the fuel cell creates electricity that way.